define os sentidos, quem faz os programas para a população dos semáforos. Vocês já perceberam quando há mais ou menos trânsito, os semáforos ficam mais ou menos tempo vermelhos ou verdes, não é? Esses programas que fazem esse no fundo, como se fosse um jogo, como se fosse uma PlayStation gigante também na cidade, é feito como foi começado a fazer aqui. E é um centro de gestão integrada, cá no Porto, nós vamos neste ano em novembro. Fiquem atentos ao nosso e-mail, que nós vamos, que vocês agora ficam na lista da Universidade de Junho e vão receber esse convite. Vamos fazer uma visita a esse centro de gestão integrada, que é fantástico, porque se vê assim, imaginem um jogo gigantesco em que se comanda o trânsito do Porto. E foi feito aqui por um colega nosso e agora está a ser aplicado nesta cidade e noutros engenheiros civis e sem tarefa nos engenheiros civis. Mais, outro exemplo, as eólicas. Nós vemos no meio das paisagens. Que engenheiros é que vocês acham, ou que engenheiros ou técnicos é que vocês acham que participam?
Mecânicos, civis.
O mecânico faz o quê?
Construir
A máquina. O civil.
decisão do local.
Civil local é o arquiteto e o arquiteto paisagista. Mais. Não vi aqui uma estrutura? Sim, a estrutura, não só a estrutura de implantação da própria torre, não é? Como uma coisa ainda mais interessante, que é estuda os trajetos do vento e as formas do vento e vai colocar as eólicas em sítios estratégicos de forma que tenha mais produção. Estão a ver os pontos abrangentes que a engenharia civil pode aplicar, mais do que a construção, mais do que as estruturas e as pontes que nós sabemos no dia a dia. Outras coisas é que vocês acham que o engenheiro civil pode fazer, que vocês tenham aprendido hoje, esta semana, e não sabiam.
A sério. Todos os espaços.
Vocês vão ver que os três vão ficar frustrados. Vocês vão responder errado. Como?
É de sono.
É de sono? Pois, é muito com sono. Mas o objetivo é, no fundo, mostrar-vos os vários âmbitos da engenharia. Estes são, assim, aqueles que me lembrei agora, que são mais extremos, que não estão integrados no nosso cotidiano e são áreas interessantes para pensar. Por isso é que nós, neste projeto, há tinha falado na engenharia mecânica, nós chamamos este projeto de Big Machine, que é para mostrarmos que a engenharia trata de uma grande máquina que é o nosso meio, não é? Não só as casas, não só os pontes, mas também todas as infraestruturas que andam à volta. Por exemplo, o abastecimento de água, a doação das águas, imaginem o que é nós não temos água. Vocês sabem que o sistema de drenagem de águas potáveis que nós temos no nosso país é responsável pela pouca taxa de doenças graves e de baixa natalidade, de baixa natalidade infantil no nosso país. Uma coisa que eu não sabia, que isso há pouco tempo. Isso é devido a termos uma rede de água potável muito grande. Pronto, mas são só alguns pormenores. Já estamos em streaming?
Sim. Já está.
Toda a gente vai falar inglês?
I'm sure.
Ok, porque nós estamos a fazer uma ligação com os outros parceiros, croatas e gregos, e eles vão nos mostrar os projetos que eles estão a desenvolver nos países deles. Não é? Eu primeiro vou fazer uma apresentação do projeto, uma coisa breve, e depois eles vão apresentar o que eles estão a fazer, e depois vão ver as nossas apresentações. Por isso é que nós queremos que vocês façam em inglês. Ou se with you during this week to make different wall solutions so they can test it and see if it's a good solution for a wall system here in Portugal. And the other two houses in Greece and in Croatia, they are going to make walls adapted to their countries. The process started with the design of the house. We made some BIM models and some AutoCAD models to test the construction of it. It's a really simple construction without screws. It's easy to make, so in any school, anywhere, someone can make a reproduction of this house. We made some models, and finally we'll work with some carpenters. And we made the house in a real size, 2.5 meters, a cube 2.5 meters. This is ours in Portugal, and this is the same house that was built in Croatia. And now the house in Greece is being built. We have a book where you have the construction manual of this house, where you can reproduce each piece. As you can see, they are really easy to make. They are constructed like Meccano. It's not very difficult to build. Here you can see one of the activities that we make with one of the schools, Clara Resident, is someone from that school. We made a 1-year activity with them, and the idea was to make them feel which are the different phases of the project. First, they came here to our faculty. You can see it over there in the photos. We went to the labs and showed them the capacities of our labs and some things that I think you made of the acoustic laboratory or the thermal laboratory, etc. And finally, we went to their school, and they made in groups. They made different proposals for wall systems, and they had to show us. They made a presentation like we're going to do after. We made some workshops with them of sustainable construction in their school. We made the VR games that we made with you, so that they can choose the different materials in a VR atmosphere and see if they were the best solutions. And then finally they made the first prototypes of the system so that they could be tested in a different environment. In the first images, we went to Mostra of University of Porto, and we made an acoustic tests because there's a lot of noise. Probably most of you have been there, and we made those tests over there. And then finally, in the last sessions, they came here to school again and made a presentation of their solutions, and we made the thermal test to see if the solution worked or not. They were evaluated by a jury, and a solution was chosen to be built in the house. We made this site where you can see our activities. We have been in lots of congresses, and we are one of other outputs that we are working on is these BIM models. The idea is to make models of different solutions and of the house, so that we can give some workshops to our students. For example, this is a manual that we are working on to give to your schools, so that you can make these activities that you have been doing this week. You can do it in your house, in your own schools. Other output that we are working on is some interactive equipment. There are small equipments that we can show the different aspects of civil engineering. I don't know if some of you have been in Mostra, University of Do you remember our equipment?
I don't think I saw it because it was last year.
It was like this.
Last year.
Yeah, they were there last year.
I don't remember.
Well, the idea is we have different equipment that, for example, these ones that show different things. For example, that one shows a thermal insulation. I think we're working with it. This one shows it's a table that we can make some structure and simulate an earthquake. And this one, for example, it's a small equipment that we can test and show how cables bridge works. And of course, in Moscow, we have the VR. That's the most requested activity in world exhibition. And here some other equipment. This one to show how an arc bridge works, and that one
Demo.
a dam works. This activity, our Nikos, our partner in Greece, will show you. This is really interesting. It's a augmented reality sandbox. What does this mean? We have this box with sand, and when we move the sand, the colors change like a plan of a topographic plan. And it's really interesting because when you stop your hand, the rain starts, so you can see how the rivers would flow over these mountains. And now I think they are making the connection between these AR samples and virtual reality. That means that in Greece they are changing the sand, and here we can put the glasses and see what's going on. So this can open really interesting path to our research. Well, we are making these handbooks so that they can be transferred to the secondary schools, and we are also creating a virtual laboratory where we are putting our activities. Other activity that we are all working on is the QR codes. What is this? We use the QR codes. Everybody knows what's a QR code. That's the Croatian partner that is working with this activity. We use these QR codes, for example, in this wall, and when we shoot to the QR code, we are linked to this page, and this page will show us what kind of wall it is. You have a 3D model where you can see all the materials that compose this wall and the specifications of the system. This is quite interesting output because we are working with our students here in the school. It's our students from the second year that are now making some of these details of the walls. But he will show you after, better than me. So, and finally these details will go to a library where we will have lots of different solutions, of wall solutions. And of course the games that we are making, and some of them that you already used, the idea is to make games about this big machine and convert it in Unity, and we can use it in a VR environment. For example, this one, we have our big machine house, and you can see which of the components of this house that we are using. You see, we click in a component, and it gives us all the details of it. Here is Joanna. We are making a handbook with all these activities that there will be in the site, so any school in any country can make the download of it and make the activities that we are making here. Then, for example, there's the sustainable construction workshop or the VR activities and so on. We have been making some multiplier events. This one is one of them. A multiplier event means that we are showing what we have been doing. The first one was a QR code lecture where our colleagues in Greece made an activity to secondary schools over there, showing the capacity of this technology. And here in Fio, João Pedro made a big lecture about this system to colleagues like you. And they made a small activity designing this room in Revit, a program that we work with. And now the ones that we are making. Just to show you that we have been visit more than 40 schools. There are some other activities that we made. For example, this one was with the students from the 12th year of Guadalajara also, and the idea was that they made the bridges of Porto in virtual reality. It was really interesting because we went to the office in this one. We went to the office of Adão da Fonseca, who's one of the best Portuguese engineers that made bridges. He made an explanation of what's a bridge, and then they made the projects of this engineer that weren't built. So it was really good to him because he could finally see their bridges that were not built. And then the students went, here are some of the images of that activity. And then the students went to SEI, that's a show of Câmara de Porto that has the connection between universities and secondary schools, and they show the activities that they made with us. This one of the bridges and this one of the house. This is when they came here. This is our other activities. We made a tower with cardboard tubes, and then they were tested before in a VR system. This is in Leisure Realm. We went to make a activity with VR, a mostra. Again with Joanna over there. Always Joanna. This was another activity that we made here just for 3 hours. And we asked your colleagues to make bridges with paper. And they just had a cardboard paper really thin. And you can see here, it's the 2 bricks. So it was really interesting for them to understand if they put the cardboard in some particular direction, it will be stronger and make like a beam. And this was another activity that we made in the Universidade Júnior, like yours. We made a bamboo tower. That before, in the beginning of the activity, they made a project in VR, and then they made the construction of it. And then we put it in a table, a seismic table, where we could test if they were earthquake resistant or not, and they were resistant. They didn't fall. Some activities. Our colleague Nikos in Greece with the sandbox that they are going to show us.
Hi guys, can you hear me? Can you see me? Hi guys, can you hear me? Can you see me? Oh, okay. And is the sound okay? Because we had some trouble last week. Oh, okay. So then I'm gonna stream using the OBS. Okay. Hello, everyone. Welcome to my presentation of the QR codes developed for the Educational Lab Big Machine project. My name is Matej. I am from Faculty of Civil Engineering, University of Zagreb in Croatia. Yes, we are that country which is in the finals of the World Cup. So we are very happy for that, and I'm personally very sorry for Portugal because I had also high hopes for them. Okay, so to the order of business. This webinar will consist of several parts. Thank you. First, I will show a brief presentation about the QR codes and how they fit into the project. After that, I'm going to show how the QR codes work. Hopefully you all have installed software for scanning QR codes on your cell phones. If not, now is the time to download an app. After that, I'm going to show how the wiki page is structured, how the codes are interconnected one with each other. And so without further ado, let's start the presentation. First, I'm gonna change the scene. Okay. This is the presentation. I'm just gonna put the stream on my other page so that I can see what you're typing. Okay. Start the presentation. Okay. I'm gonna move this a bit to the right so that you see me and that you see the presentation. Okay, as you are no doubt aware, this is a presentation which is a part of the Big Machine project, and it is a part of one of the multiplier events. As I said, my name is Matej, and I'm working along with two of my colleagues on this project. They are Professor Završki and Professor Sigmund. But it will only be me delivering this presentation, since we decided it would actually be simpler with only one of us talking and not handing out the microphone and stuff like that. This presentation, short introduction about the project. The main partner is University of Porto, where you are currently located, and the partners are University of Thessaloniki in Greece and University of Zagreb here in Croatia. The goal of the project is to promote technical sciences, especially civil engineering, among high school students in the hopes that more of you will see how great it is a profession of civil engineering, and that more of you will be interested to enroll in our faculties and learn more about civil engineering. The project is funded by the Erasmus Plus program of the European Union. Elements of the projects are the big machine house, which you saw in the presentation by Professor Rangel. BIM, or building information modeling models of the house, interactive equipment which is developed as a part of the big machine house, QR codes which will be described further in this presentation, civil engineering handbook, and multiplier events. We already did the brief introduction into the project. Following that, I will say something short about QR codes, their general information, their role in the big machine project, and we will try out the concept by enabling you to scan some of the QR codes. What is a QR code? A QR code is QR is short for quick response code. It is a graphical representation of a computer-generated code. It can be displayed both digitally, as you can see here in the corner of the screen, and it can also be displayed printed out on paper. I'm sure that all of you have seen QR codes, and you are quite well aware of them. You have seen them in promotional materials and on web pages, on apps, and stuff like that. It is actually a two-dimensional barcode. Barcode has only one dimension. It has lines, and the data is stored based on if it is white or black, and depending on the distance between two black lines. And that type of information, that type of code can only store limited amount of information, while QR codes are two-dimensional barcodes. They contain not lines, but black and white squares. As you can see, for example, here this is one square, and the existence of black or white square actually tells the computer if there is data there or not. It seems a bit complicated, but it is only the technical aspect. As I said, it has far greater storage capacity. It can contain larger amounts of data. It can contain data about it is most often used to contain hyperlinks or URL links to the website. They can be read with any device which has a camera and has a certain amount of processing power. They were developed more than 20 years ago by the automotive industry to keep track of parts in the warehouse, but the mass adoption started with the development of smartphones, which have cameras and have quite enough processing power to translate this black and white squares into other data. In this project, they are an accompanying element to the big machine house. They contain links to web pages with data about certain aspects of civil engineering. The main idea was to enable students to access data which could not be accompanied in a physical form. Let's say if you have a wall, then okay, you can write or draw on the wall, but it is not really a good permanent solution, especially if that wall needs to be used later. But you cannot have I don't know, 3D models, videos, and stuff like that in the physical environment. That is why the QR codes are designed to be printed out and put on the real world element. Let's say there's this wall behind me, and I have a QR code printed out, and I use my cell phone. I scan the QR code, and it leads me to a wiki page which has information about what the wall is, what elements it can be made of, what is the development history of a wall. We can have pictures, we can have videos about how, let's say, wall is constructed with concrete, how it is constructed using bricks. We can have 3D models of the wall where we can see the intersection, what the wall is made of, if it is made out of bricks, if it has insulation or not. So this QR codes were developed as a simple and quick means of access to information stored online, and which is related to the physical element and connecting physical and virtual environments. Some of the codes will be printed out on the very elements which the QR code connects to. In the big machine house, we have beams, we have columns, we have walls, but the house cannot contain everything which is related to construction. Therefore, the codes the codes which are on the house have hyperlinks which can lead you to additional information. You all know Wikipedia, and how when you look one article, you have all the hyperlinks which lead you to additional information about related concepts. We will see that it works practically the same way. Totally around 50 QR codes were developed in the project. 17 of them are functioning as of the moment, and they contain a large enough sample to present the intended functioning. An example of the QR code can be seen here in the presentation. If you open your phones, you can scan the QR code, and it will lead you to a glossary of the QR codes. So you will see which ones will be developed, and the ones which contain link, the ones which are blue and underlined, as similar as on any web page. If you can click on them, it will lead you to a page where you can see all the developed additional information. Now I will demonstrate and explain the QR code structure and elements of the individual QR codes. You can now already try out the concept. You can open your QR code reader app and try scanning some of the codes. The first one, I believe, is the same as the one before, which leads you to the glossary page. Another one leads you to the page. Okay, it's working. Great. Thanks, Fabio. This will lead you to the page on beams, and you can then try out later. And to answer to João, the wiki page, the structure was defined by University of Porto. In Croatia we developed what will each of the QR codes contain, and how the information will be structured. We will see that in a moment when I open the example page, the same one which you had. I'll just move this here. Okay, so this page, okay, this page is the same one which was in one of the codes, and if we click any of these blue links, we will be transported to its page. So let's open perhaps the column. We will see how it is structured. First, some general information. What a column is. It is a construction element. If we click this link, then we go to the page on what structural element is. I'll get back to the column first. What it does, it transfers loads from the upper levels of the building down to the lower levels and into the foundations and into the ground. What materials is the column made of? It can be made of concrete, reinforced concrete, steel, timber, brick, aluminum. What was the first use of columns as structural elements? You of course no doubt know that ancient Greece and Rome had columns on their buildings and on their temples, and they were not just structural elements but also a decoration. Then, for example, besides using in buildings, columns are used in other engineering structures, mostly bridges, where they transfer the loads from plates or beams down to the base and into the ground. After the initial information, we have some images which represent interesting aspects related to the columns. This is the shapes of columns based on how they are connected with other elements. We can see some steel columns. We can see some prefabricated concrete columns on a bridge, or most specifically overpass, ancient stone columns, and finally rebar and formwork, which are an important elements in construction of reinforced concrete columns. So, as I said, I opened up the structural elements, this link, and if I open its own page, now I can see that the structure is similar, some general information, images. This is, for example, a structural system, skeletal construction of reinforced concrete, an example of masonry structure, steel structure, and others. So that is that. Walls, for example, can be made out of bricks. I can open the page relating to the construction element. Brick is one of the oldest known construction materials. What can be made using bricks? We can make walls, chimneys, pillars, wall coverings, and so on and so on. Actually, I don't know if you are aware, but this is a picture of Colosseum in Rome. A lot of people don't probably know that it is not made out of stone, as most Roman buildings were made actually out of bricks, and they only had stone coverings as a facade. And this is also the Pantheon, which is also a brick building. So we have also some videos, for example, a video of brick laying. It links to YouTube, and you can all so that I don't waste time and show you all the videos. You can all watch them yourself by clicking on the appropriate links. Finally, I will open up the wiki page developed for the project. This is the project web page. If you click here, I'm gonna put this back so it is centered. Okay. If I open, you click here. This is the big machine library. I'm gonna log in so that I can edit, if necessary, some pages. Okay, so of course this is in Portuguese, and you know Portuguese way better than I do. I just know that I have to click here to get to the QR code wiki repository. This section contains the QR codes developed by the students at the faculty of University of Porto. So if you open any of them, you will see some information about the QR codes. You have BIM elements and also the QR code which will lead you to this image. But for the purpose of this webinar, we have this QR code library, which contains those QR codes developed by us in the University of Zagreb. This structure is the same as the one here in this glossary, but not all of them are transferred here in this wiki page for now. And last time I showed how to create an image, but in coordination with Fabio, we decided that it might be too technical for me to show you. So I'm just gonna show you the test page that we created last Friday. It is a page which is related to beams as structural elements. The first part is links to subsections of this wiki page. First, an image of the model, image or model of the wiki entry, depending on what is being shown. Information, same structure as we had with columns. They are structural elements, loads from slabs transferred. The beams then transfer the loads to pillars or walls, and all other additional information. We don't have images here for now. Links to video files on YouTube, and finally the QR code. So if you'd like, you can scan now this QR code. I'm gonna zoom it in so that you can see it better on your screen or your projector. And it should lead you to this exact web page. I'm gonna wait a few moments to see that if it works for you. And of course, this brings us to near the end of the presentation. And if everything works, then I'll take some questions. Fortunately, I hope that you have. Oh, thank you. Yes, it works. So this is the basic principle. this is developed with all of the other elements. We have other QR codes. Perhaps I can just show how QR codes are developed. It won't be you're welcome, Fabio. It won't be really technical. And just open up a new tab, QR code generator. You can just Google QR code generator. Google it, and you can see there are many links. Open one of them. I have copied this URL, paste it here, create press create QR code, and this should be the same as this one. Yes, it is. Okay, so thank you for your kind words, and if you have any questions, I would be glad to answer any. I'm gonna close this page and go back to the webinar. Any questions from the audience? Oh, okay. So Fabio said that we will now pass the presentation to Greece. I hope that you had a good time, that it was interesting, that you learned something new, that I was able to describe our efforts developing the QR code, and I wish you all the best in the following of the presentation, and hope that many of you will choose civil engineering as your faculty, and that you will be satisfied with your choice. So thank you everyone, and I will stop my streaming now so that we can go to Greece and to Professor Nikos and his augmented reality sandbox. Bye.